Thank you, Leon. Thank you for introducing me as being from the Dinosauria of the planet. Much appreciated. I just wanted to start out also by acknowledging Tony de Broom. I know many of you here, a number of you certainly work closely with him, but the very fact that we can stand here talking about 1.5 degree limit and the Paris Agreement is in no small measure due to Tony's efforts. And I know at the end of the day, the high ambition elements of the Paris Agreement were due to the work of a relatively small number of people, and some of the most critical actors are sitting in this room, even if at least one's on the wrong side. Apologies over there, but he's joined the fold now. But that's great. But Tony was a really important figure in that, and a great man to know. And somehow it's very interesting to sit here in New York this week, and the General Assembly Security Council getting on nuclear issues. Tony showed me where he stood as a 9-year-old boy watching the American nuclear explosions at Bikini Atoll, the rising of the mushroom clouds and so on. He told me that was how he got inspired to engage in the wider world, and I think that's a lesson for us all this week as we deal not just with climate change and other things. So in some ways we've inherited Tony's dimension and energy, and I think that's up to us to take it forward. What I'm going to do now is talk about what we can do about it, what's most important. Article 2 of the Paris Agreement, of course, has what we can call in shorthand the 1.5 degree limit in the Paris Agreement, holding warming well below 2 degrees, pursuing efforts to 1.5. It also includes Article 4.1, which refers to the need to bring emissions essentially back to zero. The language is rather complicated and came up at the last minute as usual in these things, but the balance between sources and sinks refers to bringing global emissions back to zero on a time frame consistent with meeting the long-term temperature goal of the Paris Agreement, determined in accordance with the best available science. Also hard-fought language. Our team had a look at this issue early this year, led by Carl, who's not here today, to try and understand what actually is needed to get into the Paris Agreement emission path. And here, I think if I can get this going, we've got a need to peak emissions around 2020, begin a sharp decline down towards zero. The blue pathway, the 1.5 degree pathway, the former 2 degree goal from Cancun and Copenhagen is here. What this means ultimately for policy, very much to cut to the chase, is we've got to get fossil fuel emissions from energy industry down to zero by around mid-century. By around 2050, in round terms, we need to have fossil fuel emissions down to zero. Now, we know, and we've read in the press, that carbon dioxide emissions are beginning to apparently flatten off. This is a historical series from 1959 through to 2016. See definitely flattening off here going on of the CO2 emission curves through oil, coal gas, cement gas flaring. Now that's very, very interesting. The question is, what's going to happen next? Is this really a flattening off, presaging a deep reduction, or what is going on out there? So I'm just going to step through that and then come to some conclusions about what it means. Coal production has, I see that you're missing a figure here, but coal production has basically dropped by about 6.2% in 2016. It's a graph that's shown, it was shown a drop here. World coal production is down, driven in part by retirement of coal plants in the EU, US, slowdowns in the US, in China and India, and other things going on in the coal market. Now looking at the time series, explaining this peaking of, flattening off, leveling off of global CO2 emissions, you can see here, coal has begun to drop, as I mentioned. Where it has to go in the future, though, is more interesting. The International Energy Agency's recent reference pathway, published earlier this year, part of the G20 process actually, show that likely, without further policies, emissions from coal remain flat. Where they have to go for a 2 degree pathway and 1.5 degree pathway is way down quickly towards zero. For natural gas, you can see here that natural gas emissions haven't peaked. They are continuing to increase slowly. Where they would have to go, or where they would go without further policy, is continuing to increase. Where they would need to go is, as they will peak a bit, as we start to replace natural gas in coal plant for a while, and the electricity sector would then ultimately begin to drop to low levels within a decade or so. Similarly for oil, oil hasn't peaked either, still wobbling around in the demand curve up here. The IEA reference scenario shows a gradual increase, but in the 2-degree world, emissions have to drop as electric vehicles begin to take over the transport markets and other technologies come in efficiency and so on. So the question now is great. We've seen CO2 emissions levelling off and peaking. What do we see from the current level of NDC ambition and policies out there? What does that tell us about the likely trajectory of future CO2 emissions, and hence on the peaking question? What we see here is some work that the Climate Action Tracker has done, looking at current policies, pushing up still strongly. The NDCs are a bit lower still, but heading towards still a relatively high level of warming. We have for the NDCs about 2.8, say close to 3 degrees warming from the NDC commitments under the Paris Agreement. Current policies way above that, 3.5 degrees, maybe higher. So that points to the fact that there is an underlying momentum going on in the global economy, in individual countries, which is pushing emissions up. So the question then is, well, where are the sources of emissions growth coming for the next 10 or 15 years? And having a look at this is quite interesting, because we see that OECD countries are projected to reduce emissions. This figure shows coal, gas and oil here, and we see the OECD, the EU is meant to reduce emissions under current policies. We see a balance in some regions, North America. We see large growth in emissions coming between 2014, 2015 and 2030 from South and East Asia. So this gives you a picture about the likely future growth of emissions from current policies, not reflecting the implementation of NDCs. And you can also see this tells you something about the likely sources of emissions from individual fossil fuels, coal, oil and gas. The decrease happening is not sufficient to compensate for the decrease in emissions happening in some regions is not sufficient to compensate an increase in others. Most of the growth coming from India, China and Southeast Asia, and coal will lose importance in the emission growth. But that's not the end of the story, of course, because we don't just want to stop the growth of emissions, they have to be reduced substantially. So if you look at the next question, well, what does this mean if you wanted to get into a Paris Agreement pathway? What are the largest sources of emission reductions needed and from which fuel? So summarising this, we see here in this figure the projected increases coming from current policies and where emissions need to go to get onto the 1.5 degree pathway. So you see that for coal, you need the biggest reduction. For oil, a smallish reduction. For natural gas, maybe even a small increase as we replace coal in the power sector with natural gas and other systems. So the largest part of the problem actually is coming from coal. We have to really crack on and deal with the coal issue if we're going to get into the Paris Agreement pathway. Now, having a look at the coal issue also means having a look at what is going on in investments and plans out there in the rest of the world. This is some work that we published late in 2016, looking at the amount of coal that's being planned by countries. And here you see the 1.5 degree emission pathway, 2 degree emission pathway. And then you're looking at the actual current coal capacity, the emissions that would come from this, if the existing coal plant ran to their average lifetime in the economies in which they're operating. So one lesson here is that current coal capacity, if it goes to the end of its planned life in many economies, has more emissions that are consistent well and truly with the 2 and definitely far above that for 1.5 degrees. The announced and planned capacity would add to that significantly. So here is the major rub in the issue, that we're a long way from getting onto a trajectory where we can be confident that the coal sector is moving into a pathway even remotely close to the Paris Agreement, as opposed to a level of warming that might take us back to the era of the dinosaurs, 4 to 5 degrees above the present time. I'm a warm-blooded species. I love my heat, but that would be too hot. So we have a big issue out there of stranded assets. We know that current plans in many regions are actually quite inconsistent with the Paris Agreement. Now what this translates into is that there's a need for an effective elimination of coal by 2050. And I think this will come through the new IPCC assessment. The 1.5 degree report will come up with a very similar conclusion. Coal needs to be taken out of the market effectively to zero by 2030, at least 90 to 95% reductions. The European Union also by 2030, other regions a bit differently, China 2040, other parts of the developing world by 2050. So just focusing a bit more on the coal issue, because I've shown that it's absolutely central to getting into the pathway for the Paris Agreement. Can I ask the question, what are the biggest divergences between where we need to go and current plans? So here we look at the annual reductions needed by 2030 to get into the Paris Agreement compared to where countries are headed. We see that there's a spectrum of problems going from quite small, there's still significant Turkey and Latin America, through North America, East Asia. Now you could say, well, actually, isn't North America going to be reducing coal? And it's true, it is, but it's simply not sufficient. The rate of reduction projected at present for North America is insufficient to get onto the Paris Agreement pathway. And that means it's got the third biggest coal problem. South Asia and East Asia I've already mentioned, but you shouldn't overlook South Asia. Of course, OECD Asia, Japan and Australia have reductions in coal as well, I have to point out. So this gives you a measure of where one needs to focus effort on policy to turn things around, to have any chance of getting into a Paris Agreement pathway. Now, fortunately, there's a lot to be done about it. And with colleagues at the Climate Action Tracker, we had a look at what are the 10 most important things we need to do to turn emissions. So I hope you've got another hour to sit and listen to this, but I'm just going to talk about one or two things here. The most important things here are no new coal for power plants and sustained renewables growth. And there's actually an awful lot going on out there that makes this a very different economic discussion than it was just 5 years ago. It's possible to economically sustain renewables growth. There's no technical limitation to massively increasing renewable energy sources in power supply. There's no fundamental technological limit we know of to getting renewable energy into power systems. It's very consistent with sustainable development objectives, energy security, access to energy, reduced air pollution and so on. What's going on out there in the market is also absolutely amazing. We're seeing renewable energy technology, particular solar and photovoltaics and wind, again exceeding installed coal and gas capacity in 2016, and from 2015 becoming a dominant new additional capacity even in developing countries. Why is this? It's cost. It's the money. This is an analysis done by IRENA, the International Renewable Energy Agency. It shows the trajectory of costs between 2010 and 2016 on key renewable technologies. And the bottom line message here is that the prices from one half decade to the other drop significantly. The average prices have dropped, the range drops. So these technologies are getting more and more cost effective. And if you compare them to fossil fuel costs, particularly coal, you can see why the proportion of renewable energy in new installations globally is growing. Here's the fossil fuel side of things over here, costs of hundreds of US dollars per megawatt hour for electricity production. You can see that coal is over here, coal with carbon capture and storage, natural gas with carbon capture and storage is here. What we're seeing here now, just in the changes between 2016 and 2017, is further massive drops in the cost of the technologies that compete with these fossil fuels. So whether you're talking about offshore wind, onshore wind, utility scale photovoltaics, you're seeing major drops. You're seeing stunning drops in new technologies, concentrating solar power technologies have dropped dramatically in the last few years with market-driven developments in the United States and Australia, where concentrating solar power now is down lower than can be supplied by even highly efficient natural gas. The market developments here are open market bidding arrangements in Tucson, Arizona, in South Australia, where these technologies are coming onto the market, knocking out what I would have thought 2 years ago was impossible, natural gas peaking power supply. So that's changing the fundamental economics of this. We know now that cheap, clean coal fights poverty is a myth. It's well and truly debunked by daily observation in developing countries with major air pollution problems, with during heat waves, coal plant not being able to produce enough electricity, a factor that Adele referred to in a slightly different context. We know that it's not cheap. It's only cheap in some contexts because we're not factoring in the real costs of running coal plant, air pollution, and so on. It's got large-scale environmental and social consequences. So now just to wrap up the question, at the beginning, are CO2 emissions peaking? Well, they've clearly levelled off, and it's clearly due to reductions in coal use due to the factors I've outlined, but they probably haven't peaked. Current policies globally, based on a bottom-up assessment we've done, complementing the International Energy Agency, indicates that growth is likely to resume due to the growth of emissions principally from gas, oil and coal in that order. Coal has the lowest projected growth in emissions of all the fossil fuels out for the next 10 years, but coal has to make the largest reductions for the world to get onto the Paris Agreement emissions target. Ryan's just conducting a bit of performance down there, if you're okay, Ryan. Coal needs to be phased out to achieve the Paris Agreement temperature goals. That's the bottom line. It's absolutely essential to both the peaking of carbon dioxide emissions and the initiation of that phase of very rapid global greenhouse gas reductions that need to be well and truly underway from the mid-2020s for the following decades. The electricity sector, in all of the models, show it has to be the first to decarbonise. It needs to reach zero emissions by 2050, and it can, due to the accelerated deployment of renewables, along with electrification of transport. These are the key developments that need to happen in the next few years. I was in a meeting in London last week, actually I think it was the week before, and there were representatives from India, China, Japan, and one of the most interesting things came from someone from the Indian National Thermal Power Corporation, who made the observation that in India now, for more than half of the thermal power plant, it's more expensive to produce a marginal kilowatt hour from those plants than it is to install a new photovoltaic power station. So already we're seeing a rapid and massive transition in the market, which makes this a very cost-effective option for developing countries, and one that I think inverts the traditional economic discussion about bearing the burden of economic transitions involved. So thanks for your attention and patience with this. Thank you.